All right, so welcome. I'm Stephanie, your instructor, and this is our first live session. So the way these work is I'm basically going to be going through a lesson. It's recorded. Um, so if you speak up, like if you use your microphone, that is going to show up on the recording. If you have your webcam on, that doesn't unless you speak. Otherwise, if you're sharing, I'll be sharing my screen, and that's just going to be the only thing that's going to be on the recording. So I just want to give you a heads up about the voice aspect. So if you decide to ask a question verbally, that does show up on the recording. But if you have a question and you do it through the chat, that does not show up on the recording. So up to you which method you want to ask questions as we go through this, but just wanted to put that up front. So after I go through everything, then I have to process the recording, do any editing as needed, and this will get emailed out tomorrow. So it usually gets out the next day since I'm doing it in the evening, and then I work on my editing and everything in the morning. So that's how this kind of works. So you're welcome to interrupt me at any time with any questions on what we're going over, which is order of operations today. So we're just going to cover the basics. I don't feel like the order of operations is really addressed in the textbook very well. It's like briefly mentioned, not really covered too much in there. So I wanted to make sure that we go more in depth because pretty much everything we do in algebra essentially follows the order of operations. When we solve, we kind of do the opposite of order operations. When we do a lot of things such as function transformations and we start manipulating functions, we do follow the order of operations. So it's really important to know the order of operations forward and backwards because we do it both ways. So it really is one of the foundations to algebra. So really, really important. So I'm going to start by sharing my screen. All right. And this presentation, like the PowerPoint where I will be showing work and everything like that, I do also include that when I email the recording out so that you'll have a hard copy of anything that I write down. So, it's up to you whether you want to take notes while I'm doing this or if you are just going to watch and listen, whatever works best for you. But you do get a copy of everything I write down. So, first off, we have operations. What are we talking about when we talk about math operations? So we've got the arithmetic operations. So these are the things you learn when you're in elementary school. Adding, subtracting, multiplying, dividing. And then we also include exponents, square roots, absolute value, things you do to numbers, basically. Those are arithmetic operations. And the order of operations is basically the order that you do these things. So when we only have numbers, they're called arithmetic operations. But once you start throwing in letters, which we do when we start simplifying expressions, then they're called algebraic operations. The word algebra just basically is saying you've got variables or letters involved. It's not just purely numbers. But the rules are the same whether you have only numbers or if you have numbers and letters. The order is the same. Everything is the same. So, interesting facts. The order of operations did not get standardized until recently. So, what this means is that before we started standardizing these things, people could do them in different orders. So, it's amazing that they were able to do anything with math when it wasn't a standard order to do these things. So, the order that we do grouping symbols and exponents. So the grouping symbols are if you have things in parentheses, you have things in brackets, curly braces, absolute values, and then exponents, which also includes square roots, cubed roots, those kind of things. Doing those first, basically making those your priority, didn't come about until around the 1600s. And that's when that started becoming the standard across the world, that's the order that you prioritize those. So order of operations, we always start with grouping symbols. You've probably heard the term Pemdas, or please excuse my dear Aunt Sally, which is a way to remember it. And the first part of that is P for parentheses. But it's more than just parentheses. It's anything that groups things together. So you can have brackets, absolute values, braces. If you have things going on inside square roots, if you have fractions with things going on top or in the bottom of a fraction, anything that's kind of grouped together, that is all done first. So the acronym Pemdas is a simplified version of the order of operations because it's so much more than just parentheses. Then the E stands for exponents, but it also means roots, radicals, cubed roots, fourth roots. So while we use E when we have the shortcut Pemdas, it's more than just exponents because it's also roots. So it's really important to realize that this acronym Pemdas is a guide. It's not the strict order because there are so much more things part of these steps than is in the abbreviation for Pemdas. There's so much more than what's written there. So grouping symbols come first, then we do any exponents. Then we've got multiplication, division, and then addition and subtraction. And that was standardized recently in the 1900s. So even as far back like in the 50s, it wasn't fully standardized, the order for those. So when you see these things on the internet where people are arguing about the order of operations, a lot of it is because it wasn't standardized until recently. And so people recently were taught a different order of operations, but now we have a very strict standard that's true all across the world. So multiplication and division have priority over addition and subtraction. So multiplication and division are the M and the D in Pemdas, and then addition and subtraction are the A and the S in Pemdas. Now, a lot of people say, okay, multiplication is always before division because in Pemdas you have M before D, but that is not true. So division is the same thing as multiplication because all division can be written as multiplying by the reciprocal, which is the rule when you're dividing fractions. You multiply by the reciprocal. So division is basically the same thing as multiplication. So they're at the same level. You have to do those left to right in the order that you see them. So we read left to right, so we do the math left to right. So sometimes division is done before multiplication if it's the thing that you encounter first when you move left to right. And then addition and subtraction. So subtraction is adding a negative. So subtraction is basically addition. So those are also at the same level. So you have to do those left to right in the order that you see them. So sometimes you subtract before you add because you're going left to right. So we have this acronym Pemdas, but it's a guide because it doesn't include the other grouping symbols. It doesn't include square roots. And it's misleading because it makes you think that multiplication is always first or addition is always first, and that is incorrect. It's always whichever you hit first, going left to right. So keep that in mind, that you can't just follow Pemdas exactly as written. It's a shortcut, but there's more nuances to it. And if you're curious to learn more about the order of operations, I have a link here that you can click on when you download the PowerPoint tomorrow. You can go and you can click on that, and then you can read up more about the history of it. But while I will be writing down Pemdas because it is a very handy acronym, just remember that it is a guide and it's not strictly, the order that you have to go in. And there are actually other acronyms, because there's also BEDMAS, where B stands for brackets. I've also seen BODMAS, I believe. I don't remember what the O stands for. But that one has, and the BEDMAS and the BODMAS both have division before multiplication there, because they're at the same step. So while in America we use PEMDAS, there are other countries that use other acronyms. And the guide, what's important is understanding how it works and understanding that there's more to it than just those letters. So I'm just going to go do lots of examples. We're going to start simple and then work our way to more complicated. I have several examples, and just if you have questions, stop me along the way, and I will do my best to kind of make this as clear as possible for you guys. So here we have the directions, simplify the expressions. So one thing that's super important when you are doing math is you have to write down the directions. There are words. Math is a language, but you've got literal sentences that are with your math problems, and they are telling you what to do. There are times where you'll get an equation and there's lots of things you can do to that equation, and so the directions are key because they're telling you what you're supposed to do. So you don't want to only write down the math. If you only write down the math, you are missing the directions, and then that means when you're trying to do a quiz, you haven't made a connection, you don't realize what the directions are telling you to do, and you don't have directions in your notes that you can match up. You want to write down the directions and the math, because the directions are telling you what to do with the math. So when you see the simplify the expression, so we need to break this down. Expressions, those have no equal sign. So if you see math without an equal sign in there, then it is an expression. So that's telling you that if you saw something with an equal and without, you're not working on the thing with the equal because it says expressions. The other thing is simplify. So generally when you see the word simplify, it's telling you to follow the order of operations. So it's really important to know what that word means, because that's telling you what to do. It's a direction. I see a lot of people that are like, well, I didn't know what to do with the problem. Well, you need to pay attention to learn the words, learn the vocabulary, because they are telling you what to do. So simplify means you're following the order of operations. We're trying to get the math to as few terms as possible. So when you have something with numbers only, like we have here, you're trying to get it down to a single number. When you have expressions that include variables, sometimes it's not possible to get it down to one thing. You might have two things added together, but you're trying to get it to as few things as possible. That's what it means to simplify. So we're going to start with the problem on the left, which is 10 minus 2 to the fourth. So one thing that I recommend people do is anytime you see subtraction, write it as adding a negative. Because a lot of people make mistakes with their minus signs, or they make a mistake with their negatives. And so turning subtraction to adding a negative actually can eliminate a lot of errors. So that would be my first step, is anytime you see subtraction, write it as adding a negative. So order of operations, and Like I said, I'm going to be using the acronym Pemdas, but it is a guide, not strict. P would be any grouping symbols. We don't have anything grouped together here. So next is E, so exponent square roots. So we're going to do our exponent. So the exponent 4 is only attached to the 2. That negative is not part of the exponent. If we had parentheses around the 2 and the negative so that it was said a -2 inside parentheses, then the negative is included with the exponent. But it's not. So that 4, that exponent of 4 is only attached to the 2, not the negative. So we're going to do 2 to the 4th first. And so what that means is when you're doing the order of operations, everything else just gets written down. And when we do math, we always work vertically. So I've seen people where they write their stuff from left to right, and that's not how math works. Math goes vertically from top to bottom. So each line is a new step of math. So I'm just going to rewrite everything that I'm not touching, and then I'm going to do 2 to the 4th. So you can do that on a calculator. It's perfectly fine to use a calculator. You don't have to do this in your head. But 2 to the 4th comes out to 16. So I'm going to write that as 16. So now we have 10 plus -16. So we took care of our exponent. We don't have any multiplication or division going on. So now we're doing our addition and subtraction step. So we're basically just going to do 10 plus -16. And you can type that in your calculator. If you are not good with negative signs, you can put that in your calculator, no problem. Otherwise, you can think of this as 10 minus 16. Either way, we're going to get an answer of -6. And so when you get your final answer, it's always good to box it so that you know that's your final answer, so that it's clear, this is what my answer is to this problem. And that's going to be very helpful when you turn in your quiz work so that we know what your final answer is. Are there any questions on this example? Okay. So next one is 12 divided by 2 squared. So I'm just going to rewrite this so that I can highlight. I like to use color coding, especially with order of operations, to make it clear what part I'm working on when. So we don't have a subtraction to rewrite here. And I don't recommend turning division into multiplying by a reciprocal unless we happen to have fractions. So we're going to just leave it as a division sign. So we don't have anything grouped. So we're going to go to the exponent again. So I'm going to just highlight the exponent part that we're doing. So we're doing 2 squared. So 2 squared is 4. So I'm going to have 12 divided by 4. And then 12 divided by 4 gives us 3. So this one's pretty straightforward. It's probably easier than the one with the minus, actually, because usually once you throw in subtraction or negative signs, people do tend to make a mistake. But I think this one's actually easier. So if there's no questions, I don't see anybody typing anything. Let's start getting a little more complicated. So we've got the one on the left, parentheses, And if you've got lots of things in parentheses, when you read it out loud, we would say the quantity of 4 minus 2, which is just telling us, okay, this whole thing is in parentheses, and then cubed. So we'd say the quantity 4 minus 2 cubed. And you leave like a gap when you're saying it, like, you know, and like you kind of pause to kind of indicate you're finished the parenthesis, and then we give the exponent. So order of operations again. We have parentheses. So grouping symbols. So they don't have to be parentheses. They could be brackets. Anything that's kind of grouping things together. But here we've got parentheses. What this means is you're doing what's inside there first. So first off, I'm just going to rewrite that minus as adding a negative, just because that does make it easier for a lot of people who struggle with subtraction. Otherwise, 4 minus 2 is easy enough to kind of do without rewriting. But I just kind of want to get into the habit of that just so that I'm consistent. So when we say we're doing the parentheses, what that means is that we're doing what's inside the parentheses. So I need to do the 4 plus negative 2 before I do the exponent. So 4 plus negative 2 is 4 minus 2, that's 2. And when you simplify inside the parentheses disappear. Unless it's like a negative. If you have a negative when you simplify, you leave parentheses around it just to make sure that it's consistent. But if it's a whole number, you can remove the parentheses. And so now that just gives us 2 cubed. So then you're just doing 2 cubed, which is equal to 8. So a frequent error I see people do is that they cube the 4 and cube the 2. But that is incorrect. So do not do 4 cubed minus 2 cubed. I've seen people do that where they take the exponent on the outside and they apply it to the inside. You cannot do that if there's subtraction inside or addition. It only works if it's multiplication or division, but it does not work with addition or subtraction. So that's why we don't, why we're not doing that first. We have to simplify inside the parenthesis first, because you cannot distribute or apply an exponent from the outside to the inside if you've got addition or subtraction going on. So if we look at the example on the right here, I've got 4 cubed minus 1 cubed. So this is kind of the inverse in a way of what we did on the left, because on the left, we had to do the subtraction first and then we did the exponent because the subtraction was in parentheses. But here on the right, we don't have parentheses, so we go straight to the exponent. We do the exponent first, and then we're going to do our subtraction. Because of that, the parentheses forced us to do the subtraction before the exponent. So that's really important to understand the distinction here. So I'm, again, just rewriting that minus as adding a negative. And we can do the exponents at the same time because they are separated by basically a plus sign. So if you have things that are separated by a plus sign or minus sign, but ideally plus when you're looking at it, like when you're writing it the way that I do, those are different terms. And so you can work different terms at the same time. So we can do both of these exponents at the same time. Now notice that minus is not part of the exponent because there's no parentheses around it. That exponent is only on the 1, not that negative 1, or not on the minus sign. So 4 cubed, I think, is 64. I'm going to pull out my calculator for that. Yeah, that's 64. And then plus negative, and then 1 cubed is just 1. So we've got 64 plus a negative 1, or basically 64 minus 1, and this gives us 63. So are there any questions on either of these two examples here? Either one, the one on the left or the right? Why am I turning subtraction into adding a negative? For two reasons. One, this is actually what subtraction means. Subtraction is defined as adding a negative. And two, doing this helps a lot of people avoid making sign errors. So a lot of people struggle with negatives, especially if you end up having a minus and then a negative. So you're subtracting a negative or things like that. So by turning all subtraction into adding a negative, it helps eliminate or makes those errors less common. So that is why I'm doing it. You don't have to do this, but if you find that you are somebody that does make sign errors, you might want to go and get into this habit. So that's why I'm doing it. Are there any questions or other questions? All right. Getting more complicated. So now we've kind of gone through some simple, like 2 or 3 step ones. What kind of dog do you have? I knew she was probably showing up. I was like, sometimes she's loud enough to get on this, sometimes she's not. She is a Staffordshire Terrier, American Staffordshire Terrier mixed with an Australian cattle dog. So technically half pit bull, but she looks more like a cattle dog than a pit bull. But she is 60 pounds and she loves to sit on my lap. And she would not hurt a fly. Her name is Liberty. We've had her for a year and a half now. So we got her during the pandemic after our previous dog passed away. So you are probably going to hear her frequently on these lives because she loves to bark late at night. That is like her favorite thing to do because she's not getting attention from me. And so well, now that she's being quiet, of course she's like, oh, mom's talking about me. I better be quiet. So, okay, we've got 2 problems here. These are more complicated. And so we'll do the one on the left. And Mike says he's looking for a puppy. I strongly recommend adopting from shelters. We got her from a shelter that only takes in senior dogs. So she's like about 12 years old because the senior dogs tend to be the ones that are euthanized just because they think nobody wants them. So personally, I only adopt old dogs. But definitely it's better than going to a breeder for sure. Oh, and she's going at it again. All right, enough dog talk. So we've got 5 plus 12 divided by 2 times 6 minus 1. So again, it's just good habit to write down PEMDAS so at least you remember. Even though we're not like following it strictly, it's a guide, but it's good habit to at least write it down because at least you can have your guide written down there. Or maybe what you can do is put this slide on like a note card. And then that way you can have that note card in front of you and you've got it right here in front of you. So you could just print the slide out and just like, turn it into a note card. Okay, so I'm just going to continue my habit of rewriting all these problems and to turn all the subtractions into adding a negative. Just good habit. Okay, now the one thing I do want to point out that I have a dot here, which is used for our multiplication. So you may be used to using an X for multiplication. We never, ever, ever, ever use an X for multiplication when you're in algebra because an X is a letter and it can get confusing. So you're going to want to get into the habit of using a dot, or you can put things in parentheses. So if you have two things next to each other and there's parentheses and there's no symbol between them, it's assumed to be multiplication. But I usually use the dot versus parentheses. Parentheses are used when I are in other situations. So you definitely want to get into that habit, because you don't want to get yourself confused once we start throwing in variables where you're like, is this a letter X or is this a multiplication sign? So just get into that habit. Never use the X for multiplication. So order of operations here. When writing it, you use a dot. For a keyboard, do you use the star? Yes. So if you are typing, or in Alex, this is actually a very good question. When you are in Alex or just typing, the asterisk can stand for multiplication. And that actually works in Alex, that you can use that key and it will do multiplication. And for division, it is the backslash. So you know how you see like something like this. Is it the backslash? I'm trying to think. Oops. So now that I think about it, I don't have to type it. What do I do? No, we use the forward slash, the other one. It's like, shoot, which slash is it? The shortcut for division on a keyboard is the same one that you would use if you were trying to type like a fraction. And so it is the forward slash. And so if you use that in Alex and you're trying to do a fraction, it will turn it into a fraction for you. So good keyboard shortcut, because you know the division symbol with the two dots it's not on the keyboard. So you can use those also when you're writing down on paper. So if you want to use the star on paper or the forward slash for division instead of the division sign, you can do that. That's completely fine. So order of operations, we don't have parentheses or things grouped together. We don't have exponents here, so it's multiplication and division. So we go left to right. So this is where everybody always messes up, because they want to do the multiplication first. But no, we're going left to right. So we need to do the division first, because that's the first thing that we're hitting. So we've got to do the 12 divided by 2 before we do anything else. So I have 5 plus, and then 12 divided by 2 is 6. Then I might times 6 plus -1. So now that we've done the division, now we can do the multiplication, because we're still following the order of operations and we're still at the multiplication division step. And so now we need to do the 6 times 6. So that gives us 5 plus 36 plus -1. So now we've got only addition, or you can say you've got addition and subtraction if you didn't turn the negative into subtraction, or the subtraction into adding a negative. But we work left to right here. Now, you can do this all in one step on your calculator. Your calculator is fully capable of doing this. The calculator will follow the order of operations, and it will go left to right and do it all at once. But, you know, just to make sure you're not doing any mistakes, you know, just you want to make sure you do things slow. You've got to be very detailed, just to make it obviously clear. It's good to just do one thing at a time, so it's not too confusing. So we'll do the 5 plus 36 first, which is 41. So then that gives us 41 plus -1, which then comes out to 40. So this is the type of problem that you often see on the internet, like on Facebook, where people are arguing over what the right answer is because people will do the multiplication before the division, but the division has to come first because that goes left to right. Are there any questions? Okay. So next one, we've got 100, and just getting into the habit, I'm going to write that minus 25 as adding a negative 25 times 2 plus a negative 5 and then squared. So that's minus 5 squared is now plus negative 5 squared. So order of operations, we don't have parentheses, so we want to do the exponent. And that exponent is only on the 5, not the minus. So it's just attached to the 5. So we have 100 plus negative 25 times 2 plus a negative 25, since 5 squared is 25. Now we're going to do our multiplication because that comes before any addition. So we're multiplying here a negative 25 times 2. So a negative times a positive is a negative. So we're going to get a negative 50 here. So 100 plus negative 50 plus negative 20. Whoops, I don't know why I wrote 27. 25. So now all we've got is basically addition here. We've got addition involving some negative numbers, and we're going to go left to right. So I'm going to do the 100 plus negative 50, which gives me 50. Then I have 50 plus negative 25, and that will give me 25. So you may be thinking, well, you really don't need to turn all those subtractions into adding a negative, but it is good practice to get used to what it means to add negative numbers and to really get familiar with that, especially if you start having negative numbers added to other negative numbers. So it will really help you out in the long run. Any questions? Negative times a negative is a positive. That is correct. There is a really fantastic movie from the 80s. I think it's from the 80s. It's called Stand and Deliver. It is about a calculus teacher. I think it's in California. He is teaching low-income students that they are still in elementary school level math essentially, but they're in high school. And he does summer school with them, and he gets them up to calculus level. And there's a scene in that movie where he's basically drilling into their heads negative times a negative is a positive. And they basically repeat it over and over and over again in order to get it memorized. So it's a good way to learn the rules is repetition, to just kind of repeat them over and over again. And if you want a good movie to watch, definitely recommend watching that movie. It's very good. Okay, throwing in some more stuff here. So now I'm throwing in absolute values. I'm throwing in square roots. We're getting a little more complicated here. There are an infinite number of combinations of order of operations problems, so I cannot I cannot possibly show you every single combination of a problem you will see, but I'm trying to give you enough variety so that way you have the tools to solve any type of problem you see. The thing about math is it's not about what the problem looks like. It's about what is the procedure. Because if you know the procedure, then you can solve any problem, no matter what it looks like, because you have the steps to do so. So you don't want to focus on what it looks like, what each problem looks like. You want to focus on the steps and the procedure. And that's how you learn algebra. So this example on the left, I've got 5 squared minus, and then in parentheses, we've got the square root of 9 plus 4 divided by 2. So when we rewrite this, we're going to have 5 squared. That subtraction is adding a negative, but when it's in front of parentheses, you're going to write a 1 because we're basically multiplying the parentheses by a -1 when you're doing subtraction like this. So then I've got my square root of 9 plus 4 divided by 2. And you're probably thinking, well, this is silly to rewrite the minus as adding a -1 there, but that's really important when we're starting to multiply polynomials, because you're going to have to multiply by a -1 and things like that. So it may seem silly to do it at this level, but I'm preparing you for things you need to do when you're multiplying polynomials and doing the distributive property and things like that down the road. So I'm just introducing it to you at a lower level, so that way when you have to use the same skill later on, it's familiar. So lots of reasons why I'm doing this adding a negative. And in this case, this is specifically will really connect to the distributive property. So I've rewritten it. Order of operations says that we need to simplify inside the parentheses. So now we've got lots of things going on in the parentheses at the same time. So you treat what's inside the parentheses as its own separate problem, and you follow the order of operations again. So inside the parentheses, the square root has to be done before the division because the square root is part of the exponent step. So I have to do the square root of 9. Oh, let me change that to a different color. There we go. I have to do the square root of 9 before the 4 divided by 2. Because we're inside the parentheses, and then inside the parentheses, we have to follow the order, which is exponent or square root. So I've got 5 squared plus -1. And then the square root of 9 is 3. So 3 plus 4 divided by 2. So we are still working inside the parentheses because we have not finished simplifying the parentheses yet. We're still working inside here. But now we need to do the division. So we have to do the 4 divided by 2. Maybe I'll do that in blue or darker green. There we go. Needed or blue, yeah. 4 divided by 2. We need to do that first. So it's like we're doing multiple things in here. Now, when you get more advanced, you can do multiple steps of the order of operations at once, but I don't want to confuse you guys and get there yet. So we're just going to do it one by one. So 4 divided by 2 is 2. So we end up with 5 squared plus -1 times 3 plus 2. So now we can finally start simplifying, and we do the 3 plus 2. So that gives us 5 squared plus -1 times 5. So now we've taken care of the parentheses step. Once you have a single number in parentheses, this is now multiplication, because that's a -1 times 5. So now we can move on to our exponent, which is 5 squared. So 5 squared is 25. So we have 25 plus a negative 1 times 5. So negative 1 times 5, because we need to do that multiplication. And this is where it's implied multiplication. There's no multiplication symbol. But if you have a number and then parentheses another number, that's assumed multiplication. So that gets multiplied, and that comes out to negative 5. So we have 25 plus negative 5, which then gives you 20. So this is a multi-step problem. And you can do multiple steps of these at once, but when you're just learning, you're more likely to make mistakes. So I do not recommend that you you try to do multiple steps at once. Not until you're really, really familiar with this, because otherwise you're just likely to make mistakes, and then it's going to be harder to find your errors. Are there any questions? Okay. Now the example on the right, if you see those vertical bars, those are absolute values. So they're, when it's typed out, you can clearly see a difference between vertical bars and the parentheses. When you're handwriting, you want to be very careful that you make your handwriting clear. Because if your vertical bars for the absolute values look like your parentheses, you're going to get very confused. So you just need to be very careful. Don't rush. I know quizzes are timed, but it's better to take your time than to rush, because you're more prone to make errors if you rush. So you'll do better if you don't rush. So people often get confused, especially if you see a negative in front of an absolute value, because you're not subtracting anything there. There's nothing in front. It's not subtraction. It's just some negative sign. So just like when I had the negative in front of the parentheses, we write the number 1, and then I have my absolute value. So this is, I have to be very careful to make sure my 1 doesn't look like an absolute value. So make my absolute values taller. And then I'm just going to turn my subtraction, the -3, to adding -3, just to get into that habit. Close my absolute value. Then I've got another minus sign. So I'm going to turn that into plus and negative. And then because there's not a number in front of the parenthesis, I need to stick a 1. And then I've got my parenthesis. So again, I have to make it very different. Then I have -8 plus, and then -3, because I'm turning that subtraction and adding a negative. So I'm adding in 1s and turning all my subtractions into a negative. And when you have a problem like this, where you see you've got subtractions and negative signs up the wazoo, this is the type of problem that people mess up. And this is the type of problem where turning into adding a negative can save your butt, because you're less likely to make mistakes with your signs if you have those plus signs in there to kind of help break it up. So, order of operations, it starts with grouping symbols. So that's parentheses, but it's also the absolute values. So we can do these in the same step because they are separated by a plus. So we can do these at the same time. We're going to be simplifying inside the absolute value and inside the parentheses. So I've got my -1 and then the absolute value. And then 8 plus -3, same as 8 minus 3, which is 5. Then plus -1, parenthesis, -8 plus -3 is -11. Now, not written anywhere in the order of operations is the action of actually doing the absolute value. So this is like part of the grouping where once you simplify inside the absolute value, you actually take the absolute value, which is basically whatever's inside becomes positive, and then the absolute value sign disappears. And in this case, we're going to turn it into parentheses because this is a -1 times the absolute value of 5. So this becomes -1. We're going to make that multiple or parentheses, or you can use the times symbol actually if you don't want parentheses, because that is multiplication there. So absolute value of 5 is 5 because it just makes whatever inside positive, it's already positive. So then I have my plus -1 times -11. And again, if you didn't want to do parentheses -11, you could use the dot for multiplication. So now grouping symbols are gone essentially, other than the parentheses around the multiplication of -11 there. We don't have exponents, so now we've got multiplications we're going to do. So we can do these at the same step because they are separated by the plus sign. And that is another reason why I like to, write this adding, turn the subtraction to adding a negative, because it makes it very clear that these are two separate things. So -1 times 5 is a -5. -1 times -11 is a +11. So we end up with -5 plus 11, which then gives you 6, because that's the same thing as 11 minus 5. So this one was actually less work than the one on the left. And part of that is because we were able to do few of the steps at the same time, because they were basically at the same level and they were separated. They were in different terms. There are questions. Okay, not very familiar with the absolute value. Is all it's doing making what's inside of it positive? That is correct. That's all it does. So the absolute value is defined as the distance a number is from 0. So if I have a number line and we have like a -3 here, you look at the actual distance, it's 3 away from 0. So the absolute value of -3 is equal to 3. And if you have the number 3, it's still 3 away from 0. So the absolute value of 3 is also 3. Because it's finding the distance, and distance is always positive. So you always have to simplify, basically combine to one number inside an absolute value before you can take the absolute value and make it positive. Because if I turn things positive before I added the 8 and then the -3, or before I did the 8 minus 3, you're not going to get the right answer, because it doesn't mean the same thing. Because if you do the absolute value first there and cancel out that negative with the 3, you would end up with 8 plus 3, which is 11, when the correct answer is 5. So you have to simplify inside it so that you have a single number, and then you can do the absolute value, and it just always makes the thing positive. I think it's in week 3 we will be solving equations with absolute values, and this rule, the fact that you can get the same number on the outside, but you can either have a positive or a negative on the inside, that's going to be really important. So just kind of put this aside in your head that this is going to be important later, that we'll see this again in week 3. Looking at all of this is confusing. Never been good with math. So it gets easier, with practice. Doing some of it every day, taking your time, writing down the steps that you're doing more than just the math. Like if you notice, I'm only writing down the math. All of the directions I'm saying out loud. When you take notes, anything that's said out loud should also be written down so that you have that in your notes. So like when I say we do this, the absolute value of 5 before we multiply because, I give a reason, that should be written down. So if you write down all of, what I'm saying verbally, that will help you focus on the procedure to help you learn. And it will get easier. And you can always watch this recording again and again. If you're confused, you can rewind it afterwards, and that will help. There are other questions. Okay. I don't like to have these for more than an hour, so we basically have time for one more. I have 3 more planned, so obviously I'm not going to be able to get through everything, but we'll do this one with the fraction, so that way you have something that's a little bit different. So order of operations. The fraction is considered a grouping symbol. So when you have something like this with fractions, you can treat the top and the bottom separately. So you can simplify those at the same time. Do the top and the bottom. And then within each of those, you're following the order of operations. So I mentioned that when you have things going on inside like a square root symbol, that's part of the grouping. Those are grouped together. That's still part of the parentheses step. So on the top of this fraction, we need to do the 16 minus 7 first before we do anything else. The bottom, I could, because the top and the bottom are separate pieces, they're completely separated. It's almost like you're doing 2 different problems. I can do the square roots in the bottom at the same time. So what I'm first going to do is rewrite my subtraction as adding a negative just to, get into that habit. So I've got the square root of 16 plus negative 7. Then I have my plus 3 squared over the square root of 16 plus a negative square root of 4. And that negative is really a negative 1 times the square root of 4. And I'm going to write it that way specifically because that will be helpful in a couple weeks when we start doing simplifying radicals. And you will have negatives in front of these things, and you need to understand that it's multiplied by that. So it may seem silly now, but it's going to be helpful in a couple weeks. So I'm going to turn that negative into a negative 1 there times that square root. Another thing I want to point out is that you have to make sure your square root covers the entire thing that's supposed to be inside it. If I stopped it too early, like if I did something like this, then my negative 7 is not part of that square root. So it's you have to make sure it covers everything that it's supposed to cover. And that's important in ALEKS as well. So if you have to put square roots in ALEKS, you need to make sure that everything that's underneath that line is supposed to be under that line, and that you're not missing anything or you have too much underneath there. So you got to be really paying attention to where that line ends. It's really important. So I'm going to treat these separately. So I'm going to be doing the 16 plus negative 7 on the top, but in the bottom, I can do my square roots as part of the exponent step. So I don't have to do the same step on the top and the bottom because these are separated. They're different problems. So 16 plus a negative 7 is 9. So I have square root of 9. Then I have my plus 3 squared over, and then the square root of 16 is 4 plus a -1 times, and then the square root of 4 is 2. And then again, I got to make sure, same thing with the fraction bar. You need to make sure your fraction bar covers everything in the bottom that you need it to cover. Because if it stops too soon, then it's no longer in the bottom. So I can, again, the top and the bottom are completely separate when I'm simplifying these. So on the top, I'm at the exponent step, and the square root and the 3 squared, those are both in the exponent step. 3 squared obviously is an exponent, but square root is also part of that step. So I can do those at the same time. In the denominator in the bottom, you're doing 4 plus -1 times 2, so you've got your multiplication. So again, I'm not at the same step here, but that's okay because they're separated out. Yeah, the top of this, we've got the square root of 9 and 3 squared, so they're kind of flip-flopping here. Because when we take the square root of 9, we're going to get 3. And then we square 3 squared, we're going to get 9. So it's like the numbers are flip-flopping. And then in the bottom, I've got 4 plus -1 times 2 is -2. So now I'm actually at the same spot for the top and the bottom because we're both doing adding. So when I have fractions, I usually, because whenever I do my fractions, I just tend to go to the right. So in this case, I am just going to go across, partly because I'm running out of room here, because vertically I don't have as much space. Also because I just tend to do this with my fractions. So 3 plus 9 is 12. 4 plus -2 is 2. And we need to divide, basically, or simplify fractions. So whenever I simplify fractions, I always move to the right. That's just what you're taught with fractions, that you just kind of simplify and you're kind of going to the right. So that's another reason why I do this here. So fractions are the same as dividing. So when I was talking about, oh, what slide was it? This one, where we have that division symbol, and it's basically the same to get a fraction. A fraction is division. So this is 12 divided by 2. So even though it's written as a fraction, it's actually division, and 12 divided by 2 is 6. So that is our final answer here. So are there any questions? Okay, so like I said, I had a few more that I didn't quite get to. I have one like this and one like this. So what I'm going to do is when I send out the recording along with the PowerPoint tomorrow, I'm going to put the final answer to these two on the slide. And so that way you can then see if you can follow the rules and get the answer yourself. And if you don't, then you can always email me, take a picture of what you've written down, what you did on paper, and then, ask me where you went wrong. So that way you can kind of test yourself and see if you can get the answers, because these are certainly more complicated than what we've done, but I've given you all of the steps that you need. All you need to do is follow these steps, and you just kind of go through here, and you can solve all of these even if they look completely different. So I encourage you to try to do those. So I will email this out tomorrow with the recording, so you can review the recording, watch it a second time if you need to. If you have questions on it, you can email me and ask me questions. I'm happy to answer those. And you'll have a copy of this presentation as well. So just making sure. Okay, so I know I went a little bit beyond an hour. I really do try to keep these at an hour, but sometimes they go over. Sometimes they're shorter. It kind of depends on the topic. So now that we're done or whatever, if you're wondering how do I leave this whole thing, you could just close your browser. You close the browser, it will automatically, you know, kind of kick you out and you're done. Okay, I did get a question. Could you explain how you want us to write your work down and make it into PDFs, or is it just for the homework or just for the quizzes? Excellent question. So you only need to turn your work in for the quizzes, not the homework, because the homework you have unlimited attempts, so you can just keep doing it till you get it right. But on the quizzes, you get one shot, and if you made an error, like you accidentally added instead of subtracted, the quiz doesn't know that because you just put in your final answer. So that's why we have you want to make sure that you write down on paper what you're doing during the quiz. So that way we can give you partial credit. You know, if you did almost everything right, but you just made one mistake, we can give you like 9 out of 10 points instead of a 0. So you really must turn in that work because you'll get better scores because everybody makes mistakes. I mean, you saw me write down 27 instead of 25, so it happens. But we want to give you credit, you know. So basically what you're going to do is you just write it down on a piece of paper. I'm looking, okay. I've got, let me just, this is my pre-calc class, but you know, I've got a piece of paper, number, write it down, you know, show your work on a piece of paper, and then you can use your you know, camera to take pictures, and there's lots of phone apps that can turn it into a PDF. So you just take a picture of every page, turn it into a PDF, and then upload it to Blackboard, and then we've got a copy of it. So that's what you do, and then we go and we look at your work and see if we can give you more points, because we want to give you more points. So you definitely, every quiz, every exam, afterwards, you know, as soon as you're done and you submit it, just grab your phone, take pictures, upload it, and get that taken care of. So that way you don't have to remember. And it will really benefit you, because most people earn at least 5 points back. I've seen people earn up to 10 to 15 points based off of their mistakes. So definitely, I mean, that could be a whole letter grade difference. So it's definitely worth doing. If you don't do it, I'm going to give you a 0 in the grade book. So as incentive, do it. Make sure you do it, because you do not want a 0 in for your grade. It will hurt your grade. So, and you don't have to do it on a piece of paper. If you have a stylus, you know, like a tablet like I do, you can do it electronically and then save it as a PDF. That's totally fine too. Just not everybody has a tablet. But if you have an iPad, you can even do something like that. So whatever's comfortable for you, just as long as you have it written down. I don't recommend typing because that takes forever. So just don't try to type it. It's easier to write it by hand. Other questions about other course-related things, maybe not necessarily order of operations things. Okay, I'm going to take that as a no. Okay, so the week 2 one, I am going to look at that survey that I've been emailing out. I don't know if it's going to be Thursday again. It will depend on which time has the most popular results on the survey. So it may change. This was just kind of based off of the preliminary, what people had done so far. So I will, you know, put that in the announcement on Wednesday. I'll tell you when the next one is. If it's going to be Wednesday, I'll tell you before Wednesday, so you have some time to plan. But when I figure out like what time these are going to be every week, it's pretty much going to be the same time every single week unless something comes up. And yes, the work, submitting the work is only for the quizzes, not the homework. You don't have to worry about that, just the quizzes. So all right. Yeah, it will take some time. The first week is going to seem really overwhelming, but you'll be doing the same things week after week after week. You'll always have 4 mini assignments with 5 questions each. You'll always have a quiz or exam. You're always going to be submitting your work. So you'll get into the groove. And I do encourage you that if you have time to start working ahead, because weeks 5 and 6 are the hardest weeks of the class. So You may need extra time for those weeks. So if you have time, go ahead and work ahead, not on the discussions, just on the other stuff. But then weeks 7 and 8 will be easier after that. So we're going to kind of peak a little bit after the midterm, and that's going to be the hardest part, but then it will be easier after that. So just to give you a heads up, keep that in mind. You might want to plan to spend more time on the class those particular weeks because you'll need it. So, all right. Well, I've got another one of these at 8 in 20 minutes. So I am going to cut this off so I can, get some water and stuff like that. Thank you guys so much for coming. I will see you next week. Feel free, call me, email me, contact me, and remind. I'm here to help you guys. I really am very, very available when I'm not asleep. So feel free to ask for questions, ask for help, ask questions. There are no stupid questions. I promise. I promise I am here to help you out. So, all right. I will see you guys later. I'll talk to you guys in the discussions. You guys have a wonderful evening. Bye.